Hello everyone. We are going to start on section 7.3, Lewis symbols and structures. We're going to have a few videos for this section. So in this video, the learning objective will be write Lewis symbols for neutral atoms and ions. So let's get started on that. A Lewis symbol is named after a person named Lewis, is a way of talking about just the valence electrons. So this is related to the idea of the electron configuration and the orbital diagrams that we saw in Module 6. So similar to how the orbital diagram had the most information, the electron configuration had a little bit less information, and then we have the condensed electron configuration. The Lewis symbol is taking that even one step further, because oftentimes when we're talking about predicting molecules, we don't care about the core electrons. We only care about the valence electrons, and we don't even care which energy level they are. So if it's a 6s2 or if it's a 2s2, we might expect similar behaviors. So in a Lewis structure, in a Lewis symbol, what we are showing is we are showing the number of valence electrons, and that's all we are showing. So here we're showing an example for calcium. So what we write is we write the symbol of the element, and then we write a single dot to represent each of the valence electrons in that element. So here we're showing the period 3 elements and their Lewis symbols. We're showing period 3, but the same thing would apply to basically any period of the periodic table. So if we have a 3s1, we could also have 4s1, 5s1, etc., and we would have the same Lewis symbol. So I want to say a few things about how this is set up. So generally speaking, the convention is to draw a single dot for an electron and to have those dots separate, okay, before we pair them up. So we have one dot, two dots in separate locations, three dots in separate locations. And as we're doing this, one thing that people often wonder about is how much does it matter where the dots are? It doesn't really matter in terms of if this one is on the right, you could have done it on the left or the top or the bottom. Similarly, you could have, done top or bottom for these ones, etc. The main thing is that they're by themselves. So the electron dots are by themselves before we start to pair them up together. So when we get to 4, there's one dot on every one of the 4 sides. And hopefully you can see as we go down, we're seeing what is the electron configuration that corresponds to what we're showing. So here we have 4 electrons. So 4 valence electrons, so 3s2, 3p2, showing 4 valence electrons. Here we are showing 4 electrons in the Lewis symbol. After we get to 4, we start to pair up those electrons. So we're showing that here with phosphorus. We have 5 valence electrons, 2 of them are paired, and then 3 are single dots, and then 2 sets of paired electrons, and then 2 single dots, 3 sets of paired electrons, and a single dot, and then finally 4 sets of paired electrons. Again, it doesn't matter left, right, top, bottom, where you have whatever the notation is. The main thing is that you have the number of dots be the same as the number of valence electrons, and that you don't start pairing dots up until you have a single dot on each side. So those are the 2 things you need to do to have a correct Lewis symbol for an element. This works for any of the main group elements. We don't do this for transition metals. We don't do this for the intertransition metals. So only the main group elements. And it will be the same regardless of which period you're in. Okay, so we're showing period 3 here. This also works for period 4, period 5, period 6, period 2, basically for all of them. One thing we can do with the Lewis symbol is show the process by which we gain or lose electrons. So we're showing that here for these reactions where we're showing a metal losing one or more electrons. And as we do this, we start with the atom that has some electrons. We end up with an ion that does not have those electrons. So it has these ions have lost all of their valence electrons, and then the number of electrons we're showing is equal to that change. So here we have 2 electrons shown in the Lewis symbol. We have 2 electrons shown as the product. We could do kind of the opposite for a nonmetal gaining electrons. So we're showing those down here, where we start with the Lewis structure, Lewis symbol, I should say, for an atom. We show it gaining electrons. We show, so here we gained 1 electron. We have 1 more dot at the end to show that we've gained an electron and ended up with 8 electrons. When we do this, we will typically always have the metals end up with 0 electrons. The non-metals end up with 8 electrons. And so you can kind of see how that works in terms of predicting what the charges are for the elements based on how they're gaining or losing electrons and these kinds of reactions. So here we are showing some of those examples. And we can also, okay, so what we're doing here is we're showing the reaction of metals with nonmetals to form ionic compounds, and you could see how you would need to move those electrons around to get what you end up with. So another way of showing something similar to what we have already discussed in Module 2. If this is helpful to reestablish those ideas, please use that. I might ask you to do something like what we're showing up here with these just gaining or losing electrons, or definitely drawing a Lewis symbol. But if you can do this without going through this movement of electrons, then that's fine to do so. And I'm just going to say this again. I know we had a previous video about this, but the reason we're doing these Lewis symbols is because of the octet rule. And the octet rule is saying that we gain, share, or lose electrons so that we have structures that resemble noble gases. And I want to take that and go back to these reactions we saw up here to illustrate that again. So we're showing, we're ending up with these ions that have 8 electrons. These ones have 0, but that basically means they have 8 from the previous. So what was before a core electron shell becomes the valence electron shell, and it will be full. So these are illustrating this octet rule, and then in the next video we'll extend this more to covalent compounds. So the concept of the Lewis symbol is the way by which we kind of navigate the octet rule in terms of keeping track of valence electrons.